Hi, my name's Savni, and my group and I were assigned to be experts for the unit trigonometry. So I'll be summarizing the basic lesson, which was 4.1 radian measures. So let's start off with the question. A Ferris wheel turns at 3,000 revolutions per minute. Find the exact value of the angular velocity of the Ferris wheel in A, radians per second, and B, degrees per second. So we know that the formula for angular velocity is revolutions times 360 degrees, or 2 pi, all over time. So for A, we'll be using 2 pi because it's in radians, and B, we'll be using 360 degrees because we're looking for degrees per second. So for A, let's take the revolutions, which is 3,000, and then you multiply that by 2 pi, because we're looking for radians, like I said before, all over 60 seconds, because it was 3,000 revolutions per minute, and there's 60 seconds in a minute. So you multiply 3,000 by 2 pi, which equals to be 6,000 pi, all over 60 seconds. And the next step would be dividing 6,000 pi by 60, which equals to be 100 pi radians per second, which also equals out to be when you put this into your calculator, it equals 314.15 radians per second. So therefore, the exact value for the angular velocity of the Ferris wheel in radians per second is 100 pi. So moving on to B, we are looking for degrees per second. So in A, we used 2 pi, but now we're going to use 360 degrees because we're looking for degrees per second. So once you sub that in, so it's 3,000 revolutions per minute multiplied by 360 degrees all over 60 seconds. So now you multiply 360 by 3,000, which happens to be 108,000 all over 60 seconds. So once you divide these, you get 1,800 degrees per second. So therefore, the exact value of the angular velocity of the Ferris wheel in degrees per second is 1,800 degrees per second. So moving on to example 2. A carousel has a radius of 30 meters and also has a central angle of 6.25 radians. Find the length of the arc of the angle. So the general formula would be theta equals A over R, A representing the arc length, R representing the radius, and theta representing the central angle. So now here we are actually solving for theta, but in the question it's asking us to solve for arc length. So we move down and we have to rearrange the formula to A equals theta times R. So once we sub in the values given, we get A equals 6.25 times 30 meters, which gives us an end result of 187.5, which gives us 187.5 meters as our arc length. So therefore, the arc length of this angle is 187.5 meters.
Hi, my name is Amarpreet and we'll be covering 4.2 of trigonometric ratios and special angles. We'll go through the first example together. Find the exact value of the primary trigonometric ratios of the following angle, which is 2 pi over 3. When subbing this into our calculators to find out the degree, we go multiply it by 180, which gives you 120 degrees. Having known that this is also equal to 120 degrees, we also know that this is in quadrant 2. Knowing that this is in quadrant 2, we take 180, minus it by 120, giving us 60 degrees. Having said this, this is 60 degrees, or also known as a special angle. So knowing that the special angle for this is also seen in a triangle form, like looking at this side, pi over 3, which is also equal to 60 degrees, we take sine pi over 3 equals, sine is also equal to pi opposite over hypotenuse, which in this case is 3 over 2, giving us our sine value. Cos is adjacent over hypotenuse, which is 1 over 2, and tan is opposite over adjacent, which is in this case 3 over 1, or also known as just root 3. Moving on to our second example, which is determine the exact value of the following expression. Sine pi over 3 multiplied by tan pi over 6 divided by cos pi over 4. We'll be looking at our two special triangles in this case, which are right over here. So sine pi over 3, which is over here, is also known as opposite over hypotenuse. In this case, root 3 over 2. So we'll be writing that down. So 3 over 2 multiplied by tan pi over 6. Looking over here, tan is opposite over adjacent, so opposite is 1 and adjacent is 3, so root 3 actually. And that will be divided by cos pi over 4, so we can look at any of these. Cos is 1 over 2. So looking at this first part, these two can cancel out and it'll be left with 1 over 2. And since it's divided by 1 over 2, it can also be written as 1 . So that can also equal to 2 over 2, or also equal to 1, which is the exact expression of this question.